Welcome back, and welcome to the last section we're going to cover this year. This is section 6.3, and we're still working with the normal distribution. In the last section, we learned how to standardize values. So we could take a value from any normal distribution, say, wrong color, let's say our original random variable x follows a normal distribution with a mean of 12 and a standard deviation of 3. What we found out was we could take any value from this distribution, say for one individual x is equal to 8, and we could standardize this value and find out how many standard deviations above or below the mean this individual value is. We did that by calculating a z-score using this formula. And since we have all three of these values, we just plug them in. X is 8, the mean is 12, standard deviation is 3, and we get z equals -4/3, or -1.33, if we round to 2 decimal places. Once we had z, we could use either the table in the back of the book, the normal table, or a graphing calculator, and find whatever areas we wanted. So what's the area under the curve that represents z's less than -1.33? We would draw our curve, label it appropriately, find the area to the left, and we could use either the table in the book or our calculator and find that area. So we know how to find areas under the standard normal distributions curve. So this is z. This is z. Still normal, but has a mean of 0 and a standard deviation of 1. Once we calculate the z-score, this distribution turns into this one. This is the standard normal. But since we can easily standardize values from normal to standard normal, then that means we should be able to find areas under the original curve if we can find areas under this one. So that's what this section is about. We know how to find the area for z, but can we do it in the original x without necessarily, maybe, having to go through this process? Well, turns out we can. But the way in which you find this area may make this entire process optional. You'll see what we mean. Let's look at an example. In order to maintain an adequate level of fitness, it's recommended to walk 10,000 steps per day. According to Garmin Connect data, in October 2018, the average number of steps per day for users is 7,500, with a standard deviation of 1,500 steps. And in fact, the distribution of steps per day is normal in shape. Actually, let me bring up a picture of that so you can see it. Here we go. So this is October 2018, so maybe not the most recent data that exists, but here it is. You can see this is not a perfectly normal curve, but for real life data, that's pretty good. You see this unimodal, roughly symmetric shape, right? People are more likely to take a lot of steps than they are to take not very many steps. Remember, this data came from people who have some kind of Garmin device, some kind of step tracker. Like I have a watch that counts my steps. So the people who wear something like this are probably not only going to be taking 1,000 to 2,000 steps a day. They're more likely, perhaps maybe a little bit, to take more like 13,000 steps a day, right? But this is the distribution. It's centered at around 7,500, and somewhat embarrassingly, here I am, pretty much in the middle of the distribution. This is specifically for males in my age range. And if I can make an excuse very quickly, it'll be that this is from October 2 weeks of that is fall break. And during fall break, I tend to like to sit at my desk and plan lessons and not take steps. So normally, I'd be up here. But because it was fall break and I was working at home, let's push back towards the middle. All right, excuse is over. So this is the distribution we're working with. Mean of about 7,500, standard deviation approximately 1,500. So we're working with this data set. And let's see if we can find some areas, assuming this was a perfectly normal curve. I know it's not perfect, but if we assume it is. So we want to find the area under that curve. And there are going to be two methods to finding that area. You can use the table or you can use the calculator, same as before. So let's find some questions we can ask. Here's one. What proportion of users take less than 3,200 steps? Now, you can write that on the left side here. We're going to find these probabilities using the normal table first. So your left side here can be your table, and then the right side we'll get to how to do it on the calculator. So, we know from the information given here, our variable x is number of steps per day. We know that this has a normal distribution. We saw the curve. It wasn't perfect, but we're going to use that model anyway. With a mean of 7,500 steps per day and a standard deviation of 1,500. Okay, so, and we are interested in the proportion of users that take less than 3,200 steps. So if we want to turn that into a probability statement, which I think would be helpful, we are looking for the probability that the number of steps is less than 3,200. So we want to use the table first, but I think you might know what I want you to do before you go looking at that table. That's right. We sketch the curve first, always, even though it's a new section. But this curve is not the curve we were talking about in section 2. That was always using the standard normal. This is actually the original distribution of the x's. So usually in the middle, we would put 0. But here in the middle is 7,500. Now we put the number we're interested in, 3,200. That's way under 7,500, so it's going to be somewhere to the left. Doesn't matter where. Okay. Now in terms of shading, we want to shade to the left. Okay? The arrow still points us where we want to go. So we need to find that area. And we want to use the table. Okay? Table. We may have a slight issue. If we want to use this table, this is for the standard normal distribution. We need z. We don't have that yet. We have the x value that we're interested in, but we need z to use the table. So I may have said earlier that standardizing, calculating the z-score, was optional. Turns out it's only optional if you use the calculator. If you're going to use the table, you need to standardize, right? Because there aren't going to be tables for every single normal distribution. You're not going to find a table in the back of the book for where the mean is 7,500 and the standard deviation is 1,500. It would be a very large book if they did that for every single possible combination of mean and standard deviation. They only have it for z. So we have to calculate the z-score here. Same formula as before. X minus the mean over the standard deviation. We should have all three of these values. X is the number we're interested in, 3,200. we'll subtract the mean, 7,500, and divide by the standard deviation of 1,500. This is going to be negative 4,300. It's negative 43 over 15. Let me just cheat here. This is negative 2.87. Our z-score is negative 2.87. So if we want to know the probability that the number of steps is less than 3,200, that's the same thing as this. The probability that z is less than negative 2.87. And that we know how to use the table for, right? You don't have to redraw this curve. In fact, I'm a fan of using what we already have and then under these values, putting the z's. So like this would be a z of 0, right? Because now we've standardized. The mean would be 0, and this equates to a z-score of negative 2.87. And now you can pretend like it's just like before. Negative 2.87 is what we're looking for. So this is negative 2.87. It says 0.0021 there. So what proportion of people take less than 3,200 steps? About 0.21%. About 1 in every 500 people take that few steps per day. At least in October 2018, that wear some kind of Garmin device. Okay? So we can find the area under the original curve, but we have to standardize first. We are essentially using the standard normal curve here, but this proportion is the same as the one we originally wanted. We just have to standardize first. All right, table people? You just have to standardize first. Okay? So you'll find that if you're being asked for a less than, just like before, that is what the table will give you. If you were asked a greater than, you would still standardize. You would be shading to the right. And if you use the table, remember to do your 1 minus, like you normally would. And if you want the area between two values, you'll do just like before. You'll have to standardize both of the values, both of the x's, you need the z's. You'll shade in between. You'll look up both values here and take the difference in areas, just like before. Okay? So we're essentially just adding some steps onto what we already knew how to do. We're starting with the original variable, then standardizing and finding the area. Okay. So that's how you use the table. Turns out you still need to standardize. But I said that if you use the calculator, you don't have to standardize. Let's see what that looks like. All right, new question here. This one we're going to try on the calculator, so you can put it on the right side of your notes. We're going to get rid of the table, don't worry. Here's our new question. What proportion of users take more than 10,000 steps? If 10,000 is the minimum for being healthy, this is essentially asking what proportion of people are taking a healthy amount of steps per day. Okay. We want to find the probability that someone takes more than 10,000 steps. Okay. We still have our same distribution. Mean of 7,500. Standard deviation of 1,500. So we're going to use the calculator to find this answer, but we need to have our probability statement first and sketch our curve before we go looking at the calculator. So this time we want the proportion for the probability that x is more than 10,000. Okay? We sketch our curve. Again, this is the original curve. It has a mean of 7,500. We're interested in 10,000. That's somewhere to the right. And we want to shade to the right of that. So we want that area. Okay. Calculator. Remember how we got to the areas we wanted with z's? We went to second dister. Or second vars. So second, the blue key, and that says dister in blue, vars in white. We don't use normal PDF, right? No. We always go down to normal CDF. And it wants the same four things as before: lower, upper, mean, standard deviation. In the last section, we used this to find the area under the standard normal curve with the z. This time we're doing it with this distribution, with this mean and this standard deviation. But let's find the lower and upper first. Lower is the lowest or smallest z-score in our shaded area. Here, that's going to be 10,000. That's the smallest value in our shaded area. Did I say z-score? I meant x value this time. It's the smallest value in our shaded area. Now for upper, we go all the way to the right forever and ever and ever, right? Before, we use 9999. You might see a problem with doing that here. This number is actually less than this one. So what do? Let's just add some more nines. That should do it. We'll use 9,999,999. What the heck, right? We'll see if it works. Now, for the mean and standard deviation. Before, when we were talking about the z-curve, the standard normal, we always put 0 and 1 here. And the calculator is even trying to tell you that's what you want, because that's what comes up by default. But we haven't standardized. The mean and standard deviation are not 0 and 1 here. We're using this. These are our parameters. The mean is 7,500 here. And the standard deviation is 1,500. So if we type all that in, we should be okay. So this is 10,000, 9999999, 7,500, 1,500. Paste, enter. And I get 0.0478 if we round to 4 decimal places. .0478. So that would suggest that approximately 4.78% of people took at least 10,000 steps per day as of October 2018 who wear a Garmin device. But notice, if we use the calculator, we don't have to standardize. If we're using a distribution other than the standard normal, we just put in the parameters that we have, and it will automatically find the right area. Using the table, we have to turn it into z. We have to standardize and find the z-score because that's all the table has. But using the calculator, we don't have to standardize. We can use these parameters and plug them straight in. For me, if I'm given the probability of, if I need to find the probability of something, and I'm using x, not z, if I'm using some other normal distribution with some other parameters than 0 and 1, I'm using the calculator because it's really easy to just plug this in. You don't have to do that extra work of finding the z-score. That's just me though. If you want to use the table, find the z-score for this, and then use the table to find the area, that's up to you. And in fact, it might be good practice, now that you know both ways of doing this, see if you can answer this question using the table and answer that question using the calculator, and make sure you get the same answers. That will give you an idea as to whether you really have this down or not. Let's see. Maybe I'll give you one more problem, and I'll let you choose which way you want to solve it. Sound good? Let's try it out. Okay, last question for today. Right over there. What proportion of users take between 7,000 and 11,000 steps? Between 7,000 and 11,000. I'm going to let you try this one, and you can either use the table or the calculator, whichever you find easier. I will say it will probably take you less time to do this using the calculator for several reasons. But if you are a die-hard table person and you want to do that using the table, you go right on ahead. Just remember, the first couple things you want to do here are to write your probability statement and then draw your curve with the correct area shaded. That will help you visualize what it is you're trying to find. So take some time, pause the video, try out that problem using either method. When you're ready, come back, we'll see how you did. All right, let's see how you did. For those brave enough to try this problem using the table, I've written my work over here.
Please excuse this interruption. Students, this is just a reminder that today is the last day for the after-school program. Again, today is the last day for the after-school program. So you will need to go home on the bus or however you get home on Tuesdays and Thursdays for the rest of this school year. In about 5 minutes, students can be dismissed to the buses. If you're riding the shuttles, please make sure you go straight there so you do not miss them. Have a great evening.
Here we go. So our probability statement here, we want to know the probability that x is between 7,000 and 11,000. So we draw our curve, 7,500 in the middle, shading from 7,000 to 11,000. We're going to need to find z-scores for both of these step numbers. So for 7,000, we find our z-score, we plug in these numbers, and we get z equals negative 0.33. We find our z-score for 11,000 steps this way and get positive 2.33. So our original probability statement involving x, we can now write using z in between these two z-scores. You would look up each of these numbers in the table. The area to the left of 2.33 is 0.9901 in the table. The area to the left of negative 0.33 is 0.3707. Subtract, and you get 0.6194. So approximately 61.94% of people take between 7,000 and 11,000 steps per day. That's a lot of work, especially for a problem that asks for the area between two values. Using the table, that was always the hardest type of problem. Now we actually have to calculate the z-scores first, then do all that work. It's doable, it's not impossible, but it might take you a while. Now I'll see how it works using the calculator. Probability statement. Sketch of the curve. We go to normal CDF and plug in these numbers for lower, upper, mean, and standard deviation. And out pops the answer, 0.6207, which is a little different than what you got using the table. But what I'll say is the table, we rounded at a couple different places. We rounded the z-scores. These weren't exactly negative 0.33 and 2.33. And the areas to the left of each of those were also rounded. So this is I don't want to say wrong or inaccurate, but it's been rounded several times. That is actually an exact answer to 4 decimal places. So if you need any other excuse to use the calculator for problems like this, it gives you a more accurate answer. But on a test or something like that, I would count each of these correct, even though they're different. Okay. So that's all I wanted to cover today, is the fact that we can find areas under any normal curve. Any normal curve, right? We haven't done this before for anything other than the z-curve with mean of 0, standard deviation of 1. But look, this curve has a mean of 7,500. These numbers are huge compared to what we were using. But especially using the calculator, we can go through the exact same process, still find the area. If we use the table, we've got that extra step of turning these x values into z-scores, but then we can use the table just like we used to. So, hopefully you're a little more confident in finding areas under any normal curve. We will have one more lecture on Monday, and we will talk about, what is it we're going to do? Maybe I'll just leave this a secret. Just make sure you tune into the next video. We'll do something interesting. Now that we know how to do all this, we'll do something a little different, but still involving the normal curve. So, have a great day. We'll see you next time. Take care.